So welcome back, everybody. My clock is at least 5 past the hour, so I think we can continue with the presentations. Hopefully we have Robert Huber here, who is the next presenter.
Yes, I'm here.
Great. So Robert will tell us about machine-friendly F3 implementations. You come from Marum, University of Bremen. So please go ahead, Robert.
So I hope you can see my screen now. Yeah, Andreas asked me to give this task and to introduce a little bit into Fuji and how. And so I will try to give some practical recommendation for the implementation of a machine-friendly implementation of this principle. So what I present today, in particular Fuji, this work was carried out in the context of the FAIR project. And here in particular in task 4.5, which is about a fair assessment of research data carried out on some pilot repositories. And this task had two objectives or goals. The first one was to provide assessment metrics for the FAIR principle, of course, and some practical tools which can help to assess the fairness of research objects. And these two components or tools are addressing the priority recommendation of the Turning FAIR into Reality report, which was published in 2018 from by the European Commission. So the use case or the approach was use case based, and we identified some use cases for a FAIR assessment, which are covering more or less the whole research data lifecycle. And we focused on two priority use cases. One is about a FAIR assessment before depositing data, and FAIR has developed a tool which is called FAIR Aware, which is some kind of a FAIR self-assessment tool. And the other use case is, of course, FAIR assessment of actual research data, which shall take place after data sets have been archived in research data repositories. And the tool we developed for this scenario is called Fuji, and that was mentioned before by Andreas. So basically here is a summary of the result. We have developed some metrics, which is now published in its fourth version. The metrics list contain 17 entries, and we use 16 of these for the implementation of the Fuji tool. Fuji itself is based on or is implemented as a REST web service. It was programmed in Python based on Swagger and Flask, and this is a screenshot how the output looks like with this Swagger interface. The source code is published in open access at GitHub. You can see the link here in the left lower corner, and we have also recently published client which can be used for quick testing of individual research data. So, but back to these metrics and for FAIR principle F3. So the principle, it has mentioned before, it states basically that the identifier of the data has to be contained in the metadata. We derived one metric out of it, which actually states the same and is also based on the RDA metric F301M. So both metrics are addressing the issue or testing if data is contained simply in the metadata. This is an output what Fuji gives while testing. So it is just about checking the presence or absence of the indication of a data object identifier within the metadata. So, and this also makes it very clear that this principle is, and also the metric is very closely related to another FAIR principle, the F2 principle, which demands that data are described with metadata. So to actually check F3, Fuji therefore has to also test for the availability of metadata. And the assessment of this is based on some common habits, like call it like that, which are commonly implemented by the research data community, as well as some standards and recommendations. For example, the W3C recommendation, data on the web best practices, or these recommendation how to encode metadata, doubling core metadata in HTML, and so on. So what Fuji does is shown here in this diagram. Fuji is taking an identifier. It has to be a web actionable identifier, can be a PID, a DOI, or from where it is starting to collect metadata in various ways. The most obvious one is to retrieve metadata from the landing page content, which can be embedded there in several ways. I mentioned it before, using this embedded doubling core style, or now schema.org is frequently used, but there are some other methods available like RDFA, microdata, and so on, which can also use to embed metadata in the landing page content, hidden from the humans, but visible for machines. In addition to this, Fuji is also using embedded links, for example, typed links. I will show this later on, to discover additional metadata which are offered outside the landing page, for example, XML representations or stuff like that. And it is also checking the header, the header which has been retrieved by a HTTP response, and checks there if links are given in the header section in the signposting org way. In addition to this, Fuji is also trying to negotiate alternate content. So using this content negotiation approach, this was asked in the chat before, and both ways, this signposting and typed links header, as well as content negotiation derived content, is then used and analyzed using dedicated services or mappings to extract metadata from this. So there are a variety of options to metadata itself. Agnostic standards, there are not so many possibilities actually to expose links to the data object through the downloadable data items. So, and I will just mention the most frequent one, which is supported by Fuji, type links, signposting links, and the standards listed here in this list. So the first one I would like to show is the possibility to express links within the head section of a HTML document. And here Fuji is supporting two standards or habits. One is this typed links or web linking based on this RFC 5988. it is quite easy. What you need to do is to add a link HTML tag here in the head section of your web document and use the appropriate attributes here, like this relation type, the SRC, which is indicating the web address of the object you are linking here, as well as you can indicate the MIME type here. So there are some relation types available which are appropriate for indicating content. One is the item relation type, which is sometimes used or frequently used to indicate actually the download link for data objects directly. So this is a possibility to give the link directly here in the head section. But sometimes I've seen this quite frequently actually. Also links to external metadata are given here in the head sections, and this can be indicated by some relation types. For example, alternate relation type is frequently given, for example, to indicate links to TCAT style or the FOXML data, and recommended by the Signposting initiative is the described by relation type, which can also be used to indicate links to additional or other representations of metadata. So this is a straightforward solution to do this. I mentioned Signposting. This is an initiative which was launched several years ago, and more information on this can be retrieved here at this website, signposting.org. The way to do it is quite simple. What you need to do is to provide an additional attribute in your HTTP response header, which just consists of a comma-separated list of web links which relate to, for example, here, the downloadable link, or additional metadata. So this is, it's not really a standard, but it's on its best way to become a standard and will be proposed as a RFC soon. A very popular and emerging way to express metadata now, which is appropriate for two purposes, for search engine optimization, as well as to expose metadata for the research community, is schema.org. This was heavily promoted by the major search engines like Google and Bing, and this is the reason why it became so extremely successful during the last couple of years, and it is very well suited to expose quite detailed metadata, including links to data objects. And the way to do it is just to use this distribution property, where you can include links to the data object like is shown here, using this content URL subproperty, and you can give some additional information about this data object, like the MIME type, and so on. So this is, in my point of view, the recommended way to expose metadata as well as links to data objects. You can offer schema.org in two ways. You can either embed it in your HTML of the landing page, just like you would do it with some JavaScript code, or you can offer this using content negotiation. Both ways are recognized by Fuji. Another interesting method to indicate links to data objects is to use the TCAT metadata standard. This was also mentioned several times before. This standard is not domain specific, so therefore it is well suited to serve many research communities. It can be used in several ways. You can embed TCAT as RDFA microdata within the content of your web page, or you can offer, and this is most frequently done, offer this using content negotiation, or you can indicate a link here, of course, to this metadata using the typed links or signposting links I mentioned before. And in practice, it looks like this. It is using TCAT distribution property and also indicating a download URL here using the TCAT download URL distribution. More information can be found in the TCAT documentation on the web. So this is a standard which is well supported. And so one, well, I would say not yet implemented, but definitely coming standard which will support the inclusion of data object identifiers, and this was also mentioned in the talk before, is by Datasite. This is not yet part of the official schema, but if you take a look at this, the rather new JSON output of Datasite, you will already see this attribute which is called content URL, and which will most probably then serve to include a link to your offered data objects. But yeah, well, we will have to wait for the next release of Datasite. So, but if it is in place, Fuji will be able to discover it. And so last but not least, this has to be mentioned here. There are several ways to indicate data object links in domain-specific formats, which can be used or offered also again in using content negotiation or typed links. Both would be recognized by Fuji, but the appropriate mappers for these are not yet fully implemented. But examples for standards which can be used to do this is this ISO standard for geographical information, the EML for ecological information. Of course, DDI has something like this, and a lot more, but the implementation of this is ongoing and well, will take some time. Some concluding recommendations on how to expose data objects, because this is not only a technical issue, it also depends on how it is done in practice by data curators or data stewards. So my recommendation would be to avoid offering links to multiple unrelated data objects within one data set. So this is one example here, which contains a lot of data files which are part of these data sets, and they are, well, zip files and stuff like that. So a machine would not really know which one actually the data itself is, and it's even worse if, for example, additional metadata is be given in such collections of data files, for example, PDF files also. So this is not a good way to expose links to data objects. These is a question of granularity, and if you do curate or archive data, think about this. Make it easy for machines to actually discover the data object itself, and don't mix it with additional describing metadata objects. And a final remark, so what always is a good thing to do is to indicate also the access level of offered data objects. Sometimes I've seen that data archives are just hiding the links for protected files, but this is the third way would be to indicate access level of data objects rather than hiding the links. So these are just some recommendations which are beyond the technical implementation of these F3 principles. So thank you for your attention. If you want to play with Fuji, you can either download the code and install it on your own computer, or you can visit this Fujinet web address to test the tool. Thank you.
Okay, thank you very much, Robert, for further broadening our view on this F3 principle. So now we have our last presenter of the day, which is Philippe Consett from the UiT, the Arctic University of Norway. So he will tell us about the file level identification support that they provide at Dataverse-NO. So please, Philip, when you are ready, go ahead.
Yes, thank you. I just tried to share my screen. Can you see my screen now?
Yes.
Okay. Yeah, thank you for inviting me to this webinar, and thank you also to the Dataverse community for some input to this presentation. But before I start with the topic, just a brief introduction to Dataverse-NO. It's a national generic repository for open research data. It's operated at UiT, the Arctic University of Norway, and we have currently 9 partner institutions, which are all universities in Norway. It's aligned with the FAIR principles, and it's also Core-Trust Seal certified. And last but not least, it runs on the Dataverse repository software. So how does Dataverse and Dataverse-NO support file level identification? First, some preliminary remarks. I'm not sure whether all of the features I'm going to talk about are relevant for the F3 part of FAIR. So they will include both features that support human interaction and features that support machine interaction. And I think that the overview will still be useful for some further discussions about file level identification support in research data repositories. So how is this support provided? All file level identification support is provided through the software, through Dataverse software. So it's built-in support. And Dataverse-NO runs on the main distribution of the software, so we don't use any forks of the GitHub code. Some file level identification support features are optional at repository level, so this means that you can configure it, turn off or off. If the relevant feature is turned on or activated, file level identification is either provided automatically by the repository, although in some cases it's dependent on the file type, or it may be added manually by the depositor and or curator of the collection. So first, let's have a look at the automatic file level identification support. Maybe the most relevant feature for F3 is persistent identification. This is optional on file level at repository level, but we have activated this feature in Dataverse-NO, which means that each file is assigned its own DOI, and each new version of a file gets its own DOI, which consists of the same DOI prefix and the same dataset level suffix, but a different file level suffix. So we see here some examples with the prefix, our prefix for the repository, then the dataset level suffix, and then the file level suffix, which differs from version to version. Then there is some more granular identification support for tabular files. So this is dependent on the file format. It's supported for instance, RData, Excel, CSV, which means that each file of this type is assigned a universal numeric fingerprint, UNF, which is a semantic checksum, which identifies the content of the file independently of the file format. Each tabular file of this type is also ingested at variable level, which means that variable level information is extracted and stored, and including also the number of variables and number of observations. And this metadata is indexed and therefore searchable or findable. Then there is more granular identification support for flexible image transport system files. So far, we don't have any examples of this in our repository, but metadata of this kind of files, if there is metadata found in the header section of these files, this metadata is extracted and aggregated and displayed in the astronomy domain-specific metadata of the dataset that the file belongs to. And this FITS file metadata is therefore searchable and browsable. Then there is citation support. Each file gets its FORS11 aligned reference, including information about the author. You see this example here, author, publication year, the file name, the name or the title of the dataset, and then the file level DOI, the name of the repository I forgot to mention, the version information, and this UNF that I was talking about. Next, we have verification support. I have already mentioned the universal numeric fingerprint for tabular files, and independent of file type, we have an MD5 checksum for each file that is assigned. We also have for common file formats, the media type is identified and registered. And then let's go forward to manual file level identification support. Each file may be enriched with file level metadata, including description, a file tag characterizing the type of file, for instance, if it's a data file, if it's containing data, code, or documentation, and also provenance information, which can be uploaded in JSON format and following the W3C prof standard, and additionally also as free text description. Currently, we don't have any files using this provenance information in this format. You can also add access restriction information on a file level, including terms of access and terms of reuse. And also, you can add information about relation between files. You can add a file path so that when you download the data, it will be the file hierarchy will be preserved. There are still some issues and desirables. For instance, there is no dataset level DOI versioning. This is not yet in place yet. You may find this in, for instance, Zenodo, I think. And some of the file level identification information that I've been talking cannot be correctly harvested, for instance, through OAI PMH or schema.org. There are some of the features that may not be machine actionable yet, and we also need more granular license support, both at the dataset and file level. In the previous presentations, you have heard about FAIR assessment tools. So our repository has been or is still being assessed by EOSC-Nordic and FAIR, and we of course are interested in improving the fairness of our repository continuously. Yeah, thank you for listening.
Thank you, Philip, for sharing your experiences with file level identification. So now we have reached the point where we can address all the questions that have been posted in the chat. I'm gonna share my screen and show you a summary of all the questions there. Might be easier for us to go through them. Hopefully you can see my document where I've compiled all the questions and answers and comments now. Okay, so let's start by the first question that we have in the chat is from Kari Lahti. What were the challenges found in the assessment Fuji tool itself through the process? So I guess it's for Andreas.
Yes. Well, just to clarify what is meant here, during the process, it means here the process of assessing the various data sets, I presume. So what we have done, we started using Fuji, I guess, or testing it in September last year, and I have been in rapid or frequent contact with Robert and Anu, and also reporting things that we found through the GitHub page for that. So the challenge has really been only to try to adapt the tool to our what we see as a useful purpose, and I think this has developed very quickly into what I see as a very informative tool, which gives precise information about what is being tested and found, as we have seen from Robert's presentation today. So I'm not sure how to answer that differently. The interesting thing now is really to analyze the outcome, the output of this 1,000+ data set sample that we have, and see what are the trends, or what are actually the FAIR implementation profiles that that sort of represent different communities and choices.
Okay, thank you. And the next question is also for Andreas. So do we have any Core Trust Seal certified repositories among our sample?
Can I just, I think I got an answer to that question already from Andreas, that not only Core Trust Seal, but also Clarin and some other certifications. There was a slide about certified repositories getting a slightly higher mean score. So
yes.
That's why I...
Yeah, so that's correct. I should have answered to everyone, but so I can quickly summarize. So what we mean by certified repositories is Core Trust Seal, Data Seal of Approval, Clarin, World WDS, etc. Those are the sort of commonly recognized certification schemas for repositories that we have noted, and so if we collect all of those, I think we have about 9 or 10 of these repositories in our sample of 100 or 75 that we evaluate, and they have a significant but slightly better score in the FAIR assessments.
Okay, so the next question has actually already been answered. So it's the one by Esko on content type negotiation instead of adding metadata tags to HTML. So maybe it's just good to have it here for reference if you would like to read through the correspondence. But let's go to the following actual question that we have here that hasn't been answered yet. So it's from Joachim Philipson as well. With Fuji, I get a fail score on F3. Is it because of the escape backslashes? And here is an example.
Yeah, maybe I can answer this, and maybe just I could show it on the screen. If you use the Fuji tool, you will see what actually has been discovered by the tool in terms of metadata.
Yes, and this is an example of what was.
Yeah, and this is what you have shown here is the output for the test, and maybe it is a bit confusing because here you have two entries. One is content, and this actually is the place where the found data files would be placed. And the other one, the object identifier included, is actually the identifier of the data set you gave to Fuji, and the escape quotes are backslashes are introduced because it otherwise would destroy the JSON. So this is maybe it is the output is confusing, but this is a good example because if you have the feeling that this can be improved, please visit the GitHub page and add this as an additional issue, and we will care about this.
Thank you.
Okay, so the last question we have here has already also been answered. It's also from Joachim. What about README files holding metadata as well? And Robert has answered that README files are not ideal when it comes to FAIR, in terms of FAIR. Do we have any other questions in the chat? Maybe I can go there myself. Okay, we have one question. Maybe I can just read it out loud. So it's from Richard to Philip. Can you tell us what is machine actionable on Dataverse at the moment?
Yeah, that's a good question. I think my answer is that I don't really know, but I guess any metadata that is exposed in a machine actionable way. So since EOSC-Nordic and FAIR have been evaluating us, maybe they have an overview at hand, which, I mean, there is a lot of, I think there is a lot of metadata that is exposed in a machine actionable way in Dataverse. So, but I'm not an expert in machine actionability, so I don't really know, yeah, what you want to do with the metadata. So, but maybe some expert can.
Yeah, I can quickly refer from our study and the latest evaluations that were run on the sample yesterday, in fact. So for Dataverse, generally, so Dataverse is one of these few repositories that actually do support the F3. So I think I showed about 100 data sets are or 120 maybe in our sample of plus 1,000 that pass this test. So basically the test that Robert described in detail in his presentation. So I think 90 out of 120 data sets in our sample are Dataverse that pass this. So so that's one example of a machine actionable metadata that is provided. Furthermore, Dataverse supports, provides, well, they provided DOI, that's one good thing. It supports schema.org, so it contains schema.org metadata. It also contains Dublin core metadata and Open Graph metadata. It also declares that the data, the digital object is a data set. This is also an important thing, as opposed to an article, for instance. Dataverse also provides provenance information, some limited provenance information, I should say. And it also specifies what the content of the data element is, to a limited degree at least. So, and also it contains a knowledge representation language. So typically, for instance, RDF A. So that's examples of machine actionable metadata that is supported by Dataverse.no.
Maybe I may add that, you know, it is supported kind of by the repository, but it really depends on what the depositor or the researcher is entering into the metadata schemas when depositing their data. So because many of our researchers, they are quite from different fields, and in many of the fields there are not really metadata standards used yet. So I mean, what you get out of the system, what you put into the system. So yeah.
Okay, so I believe we have a couple of comments here in between, but if you want to elaborate on your comments, feel free to do so. But I think we can address the two questions that just came to the chat. So the first one is from Thomas Reblitz. Question on the assessment. Is it possible to derive the level of machine actionability for a specific use case based on the assessment score?
In the moment, it's not possible. So because the assessment does not actually check if machine actionability is really ensured. And the reason for this is what I mentioned before. For a machine, it is not possible to actually check if, for example, two files are given as download files to check which one is the one which shall be used for the analysis. This is one thing. And for some other aspects, well, at least it can give some hints. For example, one of the metrics is, for example, testing if if the data object itself, that the data file, for example, is appropriately described in terms of, for example, if file size or file type are given and can be verified, or if observable properties or measurement types are given in the metadata. So this gives you some hint on the machine actionability, but of course, if you want to really assess it, you have to set up your own assessment pipeline, which then tests it.
Okay, so we have one question from Richard Dennis. Were there a special configuration or third-party application required to make it machine actionable? Can you identify the organization who was successful in fulfilling this F3 principle?
Maybe Richard can explain this a little bit.
Yeah, can you hear me?
Yes.
Yeah, there's many different ways to fulfill the requirement for F3, especially in within Dataverse or in some of the other digital repositories. One of the projects that I'm working on is to make data sets more machine actionable. It had already been discussed that the README files that you often find inside the actual data sets, which actually defines the data elements within the data sets, does not make information or the data machine, fulfill the requirements for F3. I'm trying to figure out what's the best approach, aside from writing a third-party application, best approach to make the actual data sets, not the data, but the data inside the data sets more machine actionable. Sort of go down to, or go up or go down to the next level of FAIR, actually make it more interoperable to describe when the discovery is made at the data set level, when a user wants to, or researcher wants to actually find the data in the data sets, make that much more machine actionable. We have talked about issuing of the DLIs, and we talked about the description of the metadata of the data sets, but I'm talking about actually going inside the data sets and saying, oh, this data point means this data point means that at the machine actionable level.
Yeah, may I try to answer?
Yeah.
Yeah, so there are some ways how to improve these machine actionability of the data itself. But this, of course, depends on several aspects. First, it depends on the nature of data. For example, if you have measured time series environmental data, for example, so this is quite clear that if you expose your data to the community, you have to provide the measured properties, units, and so on. So this is quite clear and can be checked. But for others, for example, if you provide images or such things, this is then really hard to be improved, because actually this is hard to be connected to the metadata itself. For example, if you provide an image of a cat, right, and you state in the metadata that you have an image of a dog, then it is really hard to verify if the content matches the promise of the metadata. But yeah, I would say it depends on the purpose and the nature of the data. And this has to be clarified and implemented depending on the community needs, which can be very small, or not the needs, but the communities. Sorry.
Yeah,
yeah, it is for sure domain specific, but I was really, I would sort of cross that bridge when on the domain specific side, but was really sort of focusing on Dataverse right now, since Dataverse is one of the few data repositories that make an attempt to fulfill the requirements within F3. I do know that there's work going on in the community within the Netherlands and other places to make this happen, to actually make the data sets more machine actionable. But I just was sort of asking if any of the people in this particular session knew if there was a third-party application, because it had been intimated that the discovery of these repositories have fulfilled the F3 requirement, but I was wondering to what extent have they fulfilled that particular requirement?
I can also make a few comments. I mean, I agree with what Robert answered to this. So it depends heavily on what type of data it is, and generally the topic. So the assessment tools, they are not currently capable of testing the content of the data element, as far as I know, at least yet. But the topic of basically semantic data modeling is, I think, what you're referring to or maybe thinking of. This is a pretty large part of the FAIR data stewardship course that Fortos consultants and GoFair have done for NAIC in the Nordic and Baltic region during the last 2 years. So the last of this course was held online now in October and November. So that would be my comment to that.
Yeah, I'm a data steward, so that's why I'm keenly interested in pursuing this this thread, if you will. But thank you very much, though. I appreciate the responses I've received.
Sorry, Josefina, if I can just answer. I saw a question by Benjamin Fail earlier on regarding the use of 10 randomly selected data sets for our assessment of repositories. So yes, I agree that in some few cases this may not be representative, because there are maybe large variations within the repository. The problem that we have in evaluating all data sets in a repository is that very rarely is it possible to sort of in a simple way to extract all the identifiers. The one exception that I'm aware of is, are those that have API interfaces, such as OAI PMH. And so we are working on this now for a let's say a subsample of the repositories to expand the evaluation of those repositories that do support such API interfaces.
Okay, good that you were able to address the comment or the question that Benjamin had posed earlier on. So I guess the last question that we have for now is from Ginte, and I guess this is dedicated for Eric. It's a question on fair data points. How can they be useful to repositories, or are they meant as an alternative to repositories?
Yeah, sure. I hinted a little bit at this in my presentation. But just to be clear, the fair data point, and especially the implementations that are kind of floating around now, were originally designed as a kind of reference implementation. So it was just to show, in the absence of other good examples, what we were, what we were trying to get at with the FAIR principles. So, the FAIR data points are first and foremost kind of a demonstration platform, but indeed, the way they were conceived is that, they are these independent metadata publication platforms. So that is something you could call a repository, or maybe you have a definition of a repository and you could augment the FAIR data point as it is now with some other capabilities. Among those things that might be noted in like a core trust seal type thing. So, you could build a more robust repository out of the FAIR data point, and then that can serve as a repository in and of itself. On the other hand, you can also say, well, I have a repository. It's at a certain level of fairness at the moment, and what would be a nice solution to increasing the fairness level would be, rather than going into the legacy code of the repository itself, which might be quite extensive, to rework, but that you could just publish some of the metadata that's contained there already in the context of a FAIR data point. So essentially, the FAIR data point could be a layer that sits on top of an existing repository, helping to augment some of those FAIR features that might be missing. So it's another way of looking at it. So it's, for me, it's always been kind of a big question mark. There's this thing called the FAIR data point. How will the community attempt to reuse it? And, would there be central FAIR data points that serve a lot of different stakeholders, or is it light enough and facile enough that maybe individual researchers could launch, almost a personal level FAIR data point and expose data that way? So in laboratories, or there's very active discussion right now about through commercial sources, actually, of starting personal FAIR data points for patient medical records with in such a way that it would allow the patients to control, through various levels of consent, access to their own medical records. So this could be incredibly important, for example, in getting real world observational data in times like of pandemics, when you need to really understand very quickly interventions in a medical way. So I think the sky is the limit in how FAIR data points can be used, and it's, for me, a big question mark. I'm very curious to see how the community would eventually adopt a really distributed system like that.
Okay, thank you, Eric. I don't think we have any other questions, and we are a bit running out of time. So I'll give it over back to Bert.
Yes, thank you very much. And I can see that it's almost 12 o'clock and that some of us are getting hungry, ready for lunch. So let me just say a few words to close the session off. Of course, thanks very much for everybody staying with us, particularly to the speakers, and also to Josephine for basically the moderation of the session. Thanks very much. I trust that all of you have now at the moment enough information to see the relevance and the importance of having the repository being findable, accessible, interoperable, and reusable. Take that principle F3 into account, and that you will either take action yourself or present these requirements in your organization to your superiors so that they will act on it. Of course, if you need our help to convince others in your organization, or you need help in any other way, we are here. We are more than happy to assist, and you know, we are quite happy to run this program forward. So again, thank you very much for all your help, and enjoy your lunch in a few minutes.